Like Coach Williams said.
Poor Richard.
Back on the line.
Oh my God.
Maybe we need to pick like a scapegoat of the week. I don't know.
Oh
Let's
yeah,
see.
I'm fine with that.
As long as
not
it's not
me.
permanent.
Yeah,
Let's just use a randomized.
Just don't.
Hey, you put all our names down?
Yeah, let's just
Random?
go for
Anonymous vote.
Whoever
It's
let
anonymous vote.
Fabulous ideas. I'll take it under consideration.
No, if I let no
I
Richard, you
just
can
feel like, you know, we bugged Richard for so long, and yet
No,
he's
watch
done,
the
he really
randomizer.
has done so much for us.
Anonymous
Okay?
vote.
Hey,
Watch the
we're
randomizer.
actually, Richard, this morning, we're 3D printing the first student-created stuff from Tinkercad on the machine.
Election is
So that's
I know.
ongoing right now. We have a little lizard that someone designed from middle
It's
school
so
engineering.
close.
That's happening.
Watch the
All these-
randomizer take Richard.
Yes, it's
So,
so close to being.
Ladies, gentle peoples. Okay. We are embarking upon the next section. Yes, I know, it's not gonna be on the test tomorrow. Okay, I'm keeping the test to like the Tuesday,
Like, can we
Thursday?
just study then?
No. We are really behind where we should be, so I have to keep moving, okay? Really, we took 2 days to go through and look at sample questions for lessons 1 through 5. That's what's gonna be on the test tomorrow. You should be turning in those questions that we went over in class. You can look that over again, you can look back over those sections again, but we're not gonna take time today. I need to keep moving forward.
Will we be able to use the cheat sheet with the 2.1?
Yeah.
Oh,
With the
heck
phosphorus?
yeah,
Okay.
okay? Every time you are going to be able to use the postulates and theorems and definitions, okay? If you wanna print a copy and bring it, you can use it, okay? So you don't have to look things up. But it's okay if you don't and you're just using the computer to look those up, okay? The test that I've designed is basically like that mid-chapter quiz, but it's half the length roughly. There's 11 questions that is worth a total of 20 different points. Okay, because some of those questions were multiple points, and I have tried to make that very, very clear. Read the instructions to work out what pieces of information, because sometimes all I have to do is give an answer. Sometimes I need to, write the compound statement and give the truth value and explain. Those are worth 3. You know, if you have to give 3 pieces of information, that should be worth more than just, oh, that's C. Correct?
Yeah.
So be careful on that.
Is there?
Is there an essay? No.
Okay, like one of the ones.
No. Paragraph proof? No. Will there be on the final chapter 2 test? Perhaps. Not there yet. Okay? And I think that doing one would be good for us to do. Today we're going to learn about a different kind of proof. Okay? And I think in a lot of ways you're actually going to almost find this one easier. Okay? Today we're going to start looking at algebraic proofs. It also means that we need to make sure that we're understanding everything and how it works in algebra. Now this might actually help you guys, because I've been saying for a while your algebra is a little weak. Okay, we're not confident in our algebra. But there is information in this section that's available with your postulates and your theorems and your definitions. There are certain properties that we're going to talk about that if I'm not sure how to solve for X, I can look back at those properties to work out how to do that. Okay? So let's forge ahead. Maybe, maybe not. Oh, we're not moving forward. I have no idea.
Oh, Quincy, you broke it.
Huh?
Quincy broke it, exactly.
I broke what?
The mouse.
Wait,
We nominated you scapegoat of the week.
So.
Ah, okay, I understand. Okay.
Come on, Richard.
Big review over 2-5. We have this figure where we have A and C. here's A, here's C. And we have a line DH. A, C, and DH all lie in plane R. That's this that we see right here. I always imagine these as sheets of paper. It helps me understand what a plane is. Okay, and a sheet of paper that can slice through. We also know that B is on AC. B is part of the same line. Which option states the postulates that can be used to show that A, B, and C are collinear? Take a look at your postulates. No one cares to look them up.
Oh.
I got Elijah, I got Quincy that are like getting to those postulates. The rest of you are just waiting to be told.
Yeah, you know, I think your head.
You do.
Still
From
scared,
Coach Michael.
You're still a scapegoat for the week, but scapegoats can do the right thing too. So we are trying to find a postulate that can show that A, B, and C are collinear. To some extent, you can start reading this and go, what sounds right from everything we've done in the past?
A line contains at least 2 points.
So Jeremiah is saying this. Would
And
you
that's
agree?
2.1, I know that by memory.
2.1, postulate 2.1 says a line contains at least 2 points.
Am I
It's
right?
not 2.1?
I think that's 2.3.
What's 2.1?
A line contains at least 2 points.
Ah, 2.1 is through any 2 points, there's exactly one line.
And that still can work.
It could.
It can still work.
Maybe 2.3 might be better.
Yeah, I will agree, but 2.1 is still can work.
I would say that 2.3 is where we need to go. That a line contains at least 2 points. This is what this is. This is 2.3. True?
Yep.
And these literally don't work.
Sad.
Let's see if my mouse will work this time.
You really believe-
Yes.
Thank you.
Okay. We have the same figure. Which postulate can be used to show that AC lies in plane R? Look at your postulates. Which can show that AC lies in plane R? We were given that AC and line DH are in plane R. How can we show that line AC is in plane R?
2.5.
What does 2.5 say?
If 2 points lie in a plane, then the entire line.
If 2 points lie in a plane, then the entire line
contains those points lies in.
containing those points lies in the plane.
Where are the postulants?
Where are they?
Yeah.
Online, go to classwork, online textbook. Online textbook. Right there. You might want to print a copy out. Okay? So if we have 2 points that are in the plane, the entire line containing those is in the plane. Okay, let's look at the next one. Still the same figure. Which option states the postulate that can be used to show that A, H, and D, that's A, H, and D, are coplanar?
2.5.
What does 2.5 say?
If 2 points lie in a plane if 2 points lie in a plane, then the entire line containing those points lies in that plane.
Anyone have a different answer?
This is 2 points, please.
I put one thing on that says it says really 3 points that are on the same line. That's exactly what it says. The D and H from the same line.
points because 2 points are on the same line, but not all the points.
Oh, okay, so I don't have to be on the exact same.
Yeah, so it can be that 2 of the 3 points can be on the same line, but the third one can't be in order to define a plane. If all 3 were in the same line, it defines a line. If all 3 were collinear, it would describe a line. 2 of them can be collinear, and between any 2 points, we have a line. Okay, so it's going to be that 2 of them will be collinear, regardless, but the third one, I can't make a single line out of all 3, and therefore it's going to describe a plane. Does it make sense? Hopefully. Okay. Which option states the postulate that can be used to show that E and F are collinear? They're not in the plane. We see a line intersecting that plane. How do we know that those 2 are going to be collinear?
A line contains at least 2 points.
2.1.
Or 2.1 for
Okay.
any 2 point there.
There's exactly
2.1, for any 2 points, there's exactly 1 line. No matter where they are in space, I'm going to get exactly 1 line between any 2 points. Straight line distance. Okay, which option states the postulate that can be used to show that line DH intersects EF
2.
at point B?
2.6.
2.6 says?
The 2 lines intersect and their intersection is exactly 1 point.
So that is choice
D.
D. It's not too bad when we can look at the cheat sheet, right? Okay, when we can look at that reference guide, it makes things a lot easier.
These are the type of questions.
Ew. Which of these is an irrational number?
B.
We're here in B because we have
Survey says.
Excuse me.
What?
survey wrong.
Oh, I thought you said rational.
Irrational.
I forgot what that's.
Okay. So, we were using postulates to write paragraph proofs and to find evidence to defend, to support our deductive reasoning, right? So now, we're going to use algebra to write 2 column proofs and use the properties of equality. And this is honestly going to be a really good help for your algebra, is using these properties of equality so that we can write geometric proofs, which are going to be in 2 columns now. Rather than a paragraph, we're going to show the math and then explain the thinking. Backing that thinking, we're going to take the math and we're going to back it with postulates and theorems and properties. So, we are doing algebraic proofs, which are going to lead to 2 column proofs. And these 2 things, this 2 column proof and what a formal proof is, they are equal to one another. Okay, a formal proof is a 2 column proof. So this is not something that you need to memorize. Okay, this stuff is already in your reference guide. Okay, if you look underneath the theorem 2.1, you get to page 3 of that reference guide, and you see this. Again, the cheat sheet helps. You don't have to memorize and remember this stuff, although the more that you use it, the more that you understand it. Okay? Addition property of equality. If I have 2 sides, if I add the same number to both sides, they're still equal. Okay? When we were doing things where we had like 6x plus 7 is equal to, say 72. And we're like, okay, well, how do we get x on its own? Well, if I add the same number to both sides, I still haven't changed anything. It's still equal to one another. That's where we said, okay, let's add 7 over here, and we're gonna add 7 over here, then I have 6x is equal to 79. Okay? That's this right here. Does that help? Does that help us with our algebra? And we have this right here that we can check to see what we need to do? I hope so. Okay, we can do the same thing for subtraction. Okay? Imagine that I have the same thing, but it was a plus 7. Well, in order to solve here, I would have to subtract 7 and subtract 7, which would mean that 6x is now equal to 65. I can add and subtract the same number on both sides, subtract on both, add on both, and I haven't changed the value of anything. The values are still the same. But now I'm trying to isolate that x so it's on its own. So when I do this, I say, hey, I'm using, this goes to this when I use the subtraction property of equality. And you're going to see that on the next slide. Okay? I can also multiply both sides. I could divide both sides as long as I'm not dividing by 0. Okay? There's this thing called reflexive property that's going to come into place. Symmetric property, where I can switch, where I can just flip sides, left to right, right to left. Transitive. What does this transitive property remind you of? There's something that we've learned recently that's kind of similar to that thinking. It says if A equals B and B equals C, then A is equal to C. There was something that we were talking about just yesterday that it reminds me of. What did the law of syllogism say? Do you remember the law of syllogism? We talked about law of detachment and law of syllogism. So law of syllogism said if P goes to Q and Q goes to R, then essentially we have P leads to R. We're kind of seeing that here too. I'm not going to say it's exactly the same, but I'm seeing a pattern that is similar. If A equals B, I could say like if P equals Q and Q equals R, then P equals R. It's following that same pattern, this transitive property. Okay? Substitution, if A equals B, then I can replace A with B at any time. And then there's distributive property where if I have something like A and then in parentheses B plus C, I can distribute this A to both B and C and say AB plus AC. Okay, the good thing is you don't have to memorize any of that, but you got to know where to find it, where to look it up, and you got to work out how to use it. So here is our first example. Okay? We are solving an algebraic equation. One of these things where I say, hey, we struggle a little bit. We're good at our thinking, but we're not confident in solving these. I need to work out how to solve for A based upon all of those properties. Okay? So, we're going to have algebraic steps, and we're going to say what property supports that. Okay, here's our original equation, and so we will start with that, write original equation. And the first thing that we do is we want to distribute the numbers in front of the parentheses. 2 times 5 is 10, 2 times negative 3a, negative 6a. Negative 4 times a, negative 4a, negative 4 times 7, negative 28. And this stays the same. So in order to figure out how to get rid of these parentheses, all I had to do was apply the distributive property. I didn't have to remember it. All I had to do was look at the list to go, hey, how can I do that? You know, what do I get rid of first? The next thing is this substitution property. That if I have 10 and negative 28, when I combine them, I'm using substitution. So 10 minus 28 is negative 18. I use it again here, negative 6a, subtract 4a, negative 10a. This side remains the same. Okay, now in order to get rid of the 18, the negative 18, I need to add 18 to both sides. So I use the addition property. What have I done now? Let's go back. So here, addition property, where we add to both. Substitute because we combine those like terms again. So I have negative 10a now is equal to 110. What do you think is going to come next? Division. So now I use the division property. And I'm back with substitution. So it gives you ways to solve that equation to get what you need. Okay, this is an algebraic proof. So A is negative 11, and we've proven why using those properties. Okay, so let's do this. What's the first thing that you do? We have to write the original equation. Okay, so this is original. But what's the first thing that we should do? What did we do first last time?
The distributive property.
Distributive property. Negative 3 times A, negative 3 times 3, positive 5 times 3, positive 5 times negative A. This is distributive property. And what do I do next? Substitution. Okay. So what am I going to have next for substitution? I gather those like terms. Negative 3a, negative 5a, minus 8a. negative 9 plus 15. What's gonna be next?
Subtraction.
Subtraction. So now I have to go we're gonna say minus 8a plus 6 minus 6 is equal to minus 50 minus 6. What's next? Substitution again, because I have to get rid of this plus 6 minus 6. Minus 8a is equal to minus 56. Oh, division. Division. So now I have minus 8a divided by 8, or negative 8 is equal to minus 56 divided by negative 8. Okay, what do I do now? What comes next? A equals and how do we do that? We again, I think we have that substitution. Go back to substitution. Does this help your algebra? I hope so. I think it strengthens it. It gives you the options and what happens for those. Okay, so what's my answer? We're saying it should be D, correct? Let's see if we did it right. So we're doing the algebra kind of like we did before, but we're showing each step and we're providing the proof. Why does it work that way? Okay, that's the difference for what we're doing now, because it's going to start applying to our geometric concepts as well. Okay? So here it asks us to write an algebraic proof. If D is the distance an object travels, if the distance D is I'll eventually say it right. If the distance D an object travels is given by D equals 20t plus 5. Okay, so this is the distance, and we determine that using that equation. The time t that the object travels is given by this. T is equal to d minus 5 divided by 20. It asks us to write a 2-column proof to verify this. So what are we trying to do? What was that? You're rereading what we have? I start trying to work out, is there a way that I can reword it, paraphrase it? I'm looking at this. I start with D as a function of t, and what I need to do is I need to prove that if I rearrange this equation so that I get t on its own rather than d, it's going to equal this. So I'm trying to take this and prove that I can get to this. Does that make sense? Yes? No? Do I have it wrong? Okay, Miss Lisa have it wrong? Yes. Okay. Like, I know what I'm doing, but do I frequently make mistakes? Yes. So we're trying to prove this. So we have to begin with the original equation that D is equal to 20t plus 5. We're given that D equals 20t plus 5. And we need to prove that T is equal to D minus 5 divided by 20.
So first we'll use the subtraction method.
Okay, so let's take a look. We have to start with that original equation. D is equal to 20t plus 5. Right? And that's our given. Next, why did I say that is addition?
Oh,
Because then,
yeah.
That seems like subtraction to me.
yeah, it is.
Yeah, you're right. I'm tired.
No, well, hey, I don't make these slides, but I'm looking at this. In order to get from here to here, we didn't add 5 to both sides, we subtracted both. So I would say that this is subtraction property of equality. They make mistakes too.
Then what'd you subtract?
What are we subtracting?
The 5.
We are taking this 5 and we're trying to get rid of it. So to do that, I have to subtract 5. And on this side, I'm going to subtract 5. And that's how I get D minus 5 and just 20t on the other side. Would you agree? Okay. So I wouldn't agree with their assessment about addition, because otherwise I'd have to add to both sides. Next, I divide. All I have to do is divide both sides by 20. I use that division property. And look at that. That looks pretty similar. Is it exactly the same as before?
No,
Not quite.
You can just straight switch around the T.
And what property is that? Look at which property that is.
Transversity. And
Equality.
Symmetric. Can you find that on your list of properties? So symmetric says we can just flip it.
A equals B to B equals A.
Was that as bad as you thought it could be? Like when they first gave it to you, you're like, oh, how many steps is this gonna take? How many steps did it take? 4. Technically 4. We have to start with the given, that's 1 step. And then it took 3 steps beyond that to get T on its own.
Well, I said 2 because, I don't know, I just kind of heard subtraction division.
Okay. Okay. Says which of the following statements would complete the proof of this conjecture? Okay, so we are trying to take this and prove from there that we can get this. We're given this and we're trying to prove this. Okay, we have the area of a trapezoid and we're trying to prove how we can determine the height from knowing the area and the sides of the bases. Okay, so we don't have the information yet. They're about to show us what we have here. We have to identify what's missing. So we start with our given. That was that first equation. Here's our ending point, what we're trying to prove. They even give us the reasons of what we're going to be doing, what should appear here. if I'm using multiplication, what should appear here? How do I get from here to here? What am I multiplying? Multiplying is just using like a number that I'm multiplying by. Here's a hint. How do I get from this to this? How do I go from A to 2A? It's more obvious than you think. Is it what? How do I get from A to 2A? How can I go from 1 apple to 2 apples?
You add one.
We're multiplying. How do I go from 1 apple to 2 apples? How do I? I want this in terms of multiplication. What was that? Multiply by 2. So if I multiply this by 2, it gets rid of that, right? And I multiply this by 2 and I get 2A. So if I do that, what does this equation look like now that I've multiplied by 2? 2A is equal to, the 2 gets rid of this 1/2, and it becomes B1 plus B2 multiplied by H. Did we follow? Multiplying each side by 2 gets rid of this 1/2, because 2 halves make a whole. So it's implying like there's a 1 in front, and 2 times A is 2A. Was that as hard as you thought? Were you guys kind of psyching yourselves out a little bit? I feel like you guys were, and I don't blame you. Like when we're looking at this for the first time, you aren't confident. But it's okay to make a guess and see does it work. So they show us these choices. Which one of these is 2A is equal to B1 plus B2 all times H? We're thinking it's that one right there. I'm quite confident that we're right. Okay. Now we switch over to a geometric proof. We're still using the same method, okay, with 2 columns where we're doing the work and we're providing the properties and postulates and theorems. He does that all the time. It's kind of a consistent thing. We try every now and then. So we're given that A is congruent to B, that the measures of angle B and C are equal to each other, and that the measure of angle C is 45. And we need to prove that the measure of angle A is 90. Oh, sorry, I missed this part right here. But this is, the measure of B is 2 times the measure. This is like saying multiplying, 2 times the measure of angle C. So how do we get from here to here? Okay, we're going to be applying the same method as we did for algebraic. We need to start with the given. This is the information they gave us. Okay, we know that the measure of angle A is equal to the measure of angle B. That comes from the definition of congruent angles. Okay, so they took that first piece where angle A is congruent to angle B and said, since we know that these are congruent, we know that their measures are equal to one another because of the definition of what it means to be congruent. Okay? And as a result of this, we know that the measure of angle A is equal to twice the measure of angle C. Where does that come from? Okay, we started with this. We knew that these were equal to one another. How does it suddenly become that it's equal to twice the measure of angle C? Because the measure of angle B is equal to twice the measure of angle C. And so we've replaced this just with this because of the transitive property. So that's how we get to this next step. We've replaced the measure of angle B with twice the measure of angle C because we can using the transitive property. Okay, then we substitute in, we know that the measure of angle C is 45, so we put in 45 for the measure of angle C. So the measure of angle A is now twice 45. What do you think is going to happen next? Is that an answer? What would you do next?
Multiply right on
Substitute again. Measure of angle A is 90. Have we proven it? That's everything. That was it. 5 steps. Given, and you work your way through. We've gone from our given to what we were trying to prove in 5 steps. So we're using those properties, we're using those definitions. In some cases, we need to use the postulates, the theorems. So, here we're given 4 pieces of information. Line segment AB is congruent to CD. Line segment CD is congruent to RS. We're given the measure, the length of AB and of RS, that they're both 12. I have that wrong. We have hypothesis conclusion. Okay, we have AB is equal to 12, and we're trying to prove that RS is also equal to 12. 3 givens, and 1 thing that we're trying to prove. It says, which reason completes the proof of this conjecture? So we start out with our congruent segments. What allows us to say that AB is congruent to RS?
Using the transmissive property.
Transitive property of equality. This was similar to our P goes to Q and Q goes to R, so P goes to R. It's not like a completely valid link, but that's where my brain goes to help me remember that one, to make it easier for me to understand that one. okay? So transitive property, this leads to this. If those are congruent, those measures are equal. We know that AB is 12, therefore our S is 12. And then you notice that here, given ended up being a reason. Beyond that first step, givens can be a reason later on. And I think we're just gonna finish there for today.